Today we are looking at summarizing the data. So using the measure of central tendency first and then the spread. When we use the measure of central tendencies, we are trying to find the value in the middle of the data, sort of like an average. Mean is an average after all. So you can either use the mean, the median, or the mode. Sometimes we cannot use the mean when there is an outlier, which will distort the average. So sometimes we can have an outlier on the data, and the mean tends to then distort the average. First up, we're going to look at the mean, where mean is the sum of all values of the data set divided by the number of values in the data set. Mean is also known as the average. So an example of how we calculate the mean or the average is, let's say we have an ages of the learners in grade R, and they are all listed there for the kids. One is 6, one is 5, one is 6, and so on and so forth. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 learners, right? So what we do is we're going to take this formula here that says sum of all values, which means add all the ages divided by number, and then we count how many are they, right? So calculate the mean age. Mean is equal to sum of all values divided by number. So what we're going to do is we're going to add by saying 6 plus 5 plus 6, so that you're doing all of it correctly, plus 5 plus another 6. And then we divide by counting all of them, and there is 20, and we get the answer. So what we're going to do is we're going to add all of those, and we get, so that is 117 divided by 20, and that will give us 5.85 is the average. The median is where we look at the middle number of the data, the number that sits right at the center. That is the value right at the center of the data. So median has a rule, and that is you have to arrange the data. Preferably, I prefer arranging it in ascending order, so we're going to do that. So this one is 1356. It's already in ascending order. So what is at the center? So if you were to break this number 5 would sit right at the center of the data, and so the median here is, the median is equal to 5. If you check, there's two numbers this side and there's two numbers this side. So you have this half this side, half this side, and you have the middle right there exactly at 5. Let's try again. This time we have 1, 3, 5, 7, 8, 9. And if we leave this one and this one, this one and this one, so we say that's the half. So the number at the center will be between 5 and 7. So now what happens is that these two are the numbers between the center. So we're going to just highlight them, put them in a box. And the number between them, which we are not given, is the median. So what we're going to do now is we're going to say 5 plus 7 divided by 2, which gives us 12 divided by 2, which will give us 6. And now we say right there, the median is 6. Have the mode, which is the number that appears the most, and if we look at the value that appears the most here, it seems to be 6, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13, 6. So the mode here is equal to 6. Then we move on to the measure of spread, and using the range. So range is equal to maximum value minus minimum value, and that is, if we look at this example here, arranging, you don't need to arrange just what is the minimum and what is the maximum. In this case, this is the minimum and this is the maximum. So we can calculate the range saying range is equal to maximum minus minimum. Always write the formula, and then range is equal to 8 is maximum minus 1. Therefore, range is equal to 8 minus 1, which is 7, right? Quartiles divide the data set in 4 parts. So we're going to do an example. When we are doing quartiles, which is very new in grade 12, so I'm going to go very slowly. When we are doing quartiles, the first thing, it's very important, is to arrange your data in ascending order. So let's look at our data. It says 1, 3, 5, 7. That looks arranged, but then 2 is here, then it's 8, then it's 10, then it's 4, then this data is not arranged. So we are first going to arrange the data, starting from smallest. The smallest number is 1, so let's write 1 there. And then the next number is, and then I'm just going to cross it out to make sure I know, and then 2. So I'm going to write 2, and then 3, and then it's 4, then it's 5, then it's 6, then it's 7, 8, 9, 10, and 11. So that's what we did there. We arranged the data. Now we can go on and find the quartiles. So whenever you're going to find, even if the question says find quartile 3, never ever ever go find quartile 3 without finding the median, which is also known as Q2. So after arranging the data, the next step is to find Q2, known as the median. So here what we're going to do is, using the data that we have arranged, we're going to find the median, the middle number of the data. So since this is when it's like nicely like this, I just do this and get to the center, and therefore 6 is the center, right? Or you can count them. There's 11, which means there'll be 5 this side, 5 this side, 10, and 1 in the middle. Okay, so let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, so Q2, which is also the median, is equal to 6, right? Now we're going to find Q1. In order to find Q1, we already know that this here in the center is Q2. Once you've used the number for finding Q2, you don't use it again. Now what we're going to do is, I'm going to place my finger on the number Q2. You see, if I do that, then Q1 will come out of all of the numbers that are left on the first half, and the second half is going to be the Q3 area, right? So I'm only going to use from 5 all the way there is going to give me Q1, and 7 to 11 is going to give me Q3, right? Let's find Q1. So now I'm starting from here, and I'm saying there's 5 numbers, so 2 this side and 2 this side leaves 3. Therefore 3 here is Q1, right? So Q1 is 3. Then I come back and I say there's 2 this side and there's 2 this side, therefore Q3 is 9. Therefore finding Q3, then Q3 is equal to 9. Right? Okay, so we are done. Right, and then once we've found the quartiles, we can also be asked to calculate the interquartile range, which is calculated as a range but using only the quartiles. So in the first example, we used this data to find the quartiles. Now that we have Q1 and Q3, we can calculate the interquartile range. Q3 is 9, Q1 is 3, and that's all that they're asking for. So interquartile range is equal to Q3, which is 9, minus Q1, which is 3, and you get 9 minus 3, which is 6. I don't know why I keep writing the zeros. Then we move on to the 5-number summary, which is just minimum value. Then it's Q1, Q2, Q3, and the maximum. That is a 5-number summary. We will see this on the box whisker diagram as well. Speaking of the box whisker diagram, we need to know how to read the values on a box whisker diagram. So the 5-number summary, now that we know that the 5-number summary is minimum, Q1, Q2, Q3, and maximum. We're going to use this particular example here. This part here this is a box, and whiskers, like a cat, right? So the whiskers point at the minimum at the beginning, and at the end they point at the maximum. So basically the minimum is 70 and the maximum is 120. Very good. Okay, so now we have at the first corner here points at Q1. The second corner in the middle, remember the middle of the data, is Q2, also known as median of the whole data. And this part here will then point at Q3, right? So if we were to read here the maximum, let's see if it answers the maximum. The maximum value is 120. Q3 is 110, between 110 and 120, that would be 115 right there, 115. And then Q2 is 110, Q1 is 100. See, that's how you read the box whisker diagram. On the next lesson, we'll be doing examples and calculations. Don't miss that.